Welcome to Brain Vision.
In this problem, we are essentially doing computations and calculations, finding averages and standard deviations. Now, I know that this might seem like it's not very related to quantum mechanics, but this is essential math that you will need to know when you get to more advanced topics in quantum mechanics. So for part A, the first thing that we know is from the data we're given is that the average of j squared equals 21 squared, which is 441. Now, what we need to do is we need to find the average of j squared and notice where our squared is because that's going to make a difference in our computation. Well, this is going to be equal to 1 over n times the sum of j squared of n of j. So this is a very simple summation calculation that we can do. So this is going to be equal to 1 over 14 times this entire quantity, 14 squared plus 15 squared plus 3 times 16 squared plus 2 times 22 squared plus 2 times 24 squared plus 5 times 25 squared. Now all you have to do is plug that into a calculator and we're going to find that our j squared average is 459.57. And now for part B, we need to find the standard deviation. Now, luckily for us, we don't have too much data where we can do this by hand. So let's just make a quick table of what we're doing. We have J and we have delta J. J is going to be equal to 14, 15, 16, 22, 24, 25. Delta J is -7, -6, -5, 1, 3, and 4. Now, what we can say is we know that 6 squared is equal to 1 over n times the sum of delta j squared times n of j. So again, this is just a simple summation calculation like we did in part A. So this is going to be equal to 1 over 14 times -7 squared plus -6 squared plus -5 squared times 3 plus 1 squared times 2 plus 3 squared times 2 plus 4 squared times 5. Again, we can just plug that into a calculator and we'll find that 6 equals the square root of 18.571. So we're going to get that our standard deviation is 4.309. And now for part C, we have to verify that what we've done is correct. Well, we know that 6 squared is going to be equal to our average of j squared. Notice where our squared is minus j squared. Well, what we're going to do is we'll take 459.571. That was our calculation from part A, minus 441, and we'll get 18.571. So we can see that this correlates with what we found in part C using our standard deviation. So part B using our standard deviation. So what we've done is correct. And that is the answer to each of the parts of the problem. If you have any questions, please feel free to comment or post something in the Ask feature. I'm happy to I'm happy to answer any questions that you have. And I hope that this helps you with your current studies and your current introductory studies to quantum mechanics.